Here we have a problem on derivative. Okay, let's go over the question. Use the limit definition of derivative to find f prime of x if f of x equals to 2x squared negative 3x positive 1. Okay, first let me write the formula for finding derivative using limit definition. Here we have the formula to find derivative of a function f of x, that is f prime of x, using limit definition. Okay, so to use limit definition to get derivative of this function f of x, what I need to do is first I have to find the stuff that is equal to f of x positive h. For that, what I need to do is in the given function, this x has to be replaced by x positive h. Okay, let me do it in the next step. So f prime of x equals to limit h tends to 0. So to get f of x positive h, we have to take the given function. This x has to be replaced by x positive h. So on the right side also, we have to plug in x positive h for each x we find. So then I'll be getting 2 times x positive h the whole square, negative 3 times x positive h positive 1. Okay, so this is the stuff we have for f of x positive h negative, and now we have to write the stuff that we have for f of x, that is a given function. So for f of x we have 2x squared negative 3x positive 1, so that we can plug in for this f of x. Then we get 2x squared negative 3x positive 1. I use parenthesis because we find negative sign for f of x. So this negative sign is applicable whatever stuff we have for this f of x. For the complete stuff we have to apply this negative sign. Okay, so now it has to be the entire stuff has to be divided by h. Okay, so f prime of x equals to limit h tends to 0. Okay, now I have to expand the square of this binomial, that is x positive h whole square. For that, we can use the basic algebraic identity, that is a positive b the whole square. So a positive b the whole square. So here we have a binomial a positive b, and we have square for this. The expansion of the square of this binomial is a square positive 2ab positive b square. It's one of the basic identities of algebra. So we can use this identity to expand the square of the binomial over here. So comparing this x positive h the whole square and a positive the whole square, at the place of a we have x, and at the place of b we have h. So we have to write the expansion over here. So by replacing this a by x and b by h. Okay, let me do it. So we have 2 times x square positive 2ab, 2 times for a we have h x, and for b we have h positive b square, that is h square. And here you can distribute the negative 3 to x and positive h, then I'll be getting negative 3x, negative 3h, positive 1. Now I can distribute this negative sign to this 2x square and negative 3x and positive 1. When I do so, I'll be getting negative 2x square, positive 3x, negative 1. So the complete stuff has to be divided by h. Okay, now we have f prime of x equals to limit h tends to 0. Now I can distribute this 2 to x square and 2 to 2x h and 2 to this h square. But before that, we can simplify. Negative 3x positive 3x will cancel out, and positive 1 negative 1 will cancel out. Okay, now let's distribute this 2 to the stuff over here. So I'm getting 2x square positive 4xh positive 2h square negative 3h negative 2x square. Everything is divided by h. So here positive 2x square and negative 2x square will cancel out. So f prime of x equals to limit h tends to 0, and I find 4xh, 2h square and negative 3h. So we have 4xh positive 2h square negative 3h has to be divided by h. Okay, f prime of x equals to limit h tends to 0. Okay, here, so when I look at the terms over here in numerator, each term contains h. So h can be factored. If I factor h out, I'll be able to simplify the h in denominator. So what we can do is h can be factored. If h is factored out from the expression in numerator, so here h is factored. I have 4x left in the first term, and positive in this 2h square h is factored, and we have 2h left in the second term, and here this h is factored, and we have negative 3 left, and we have h in denominator. So now this h can be cancelled, and we get f prime of x equals to limit h tends to 0. So we have 4x positive 2h negative 3. So f prime of x equals to, now I can plug in the limit 0 for this h, then I'll be getting 4x positive 2 times 0 negative 3. So finally, f prime of x equals to, so 2 times 0 is 0. So 0 can be ignored. So the simplification of this expression is 4x negative 3. So now I got the derivative of the given function f of x, that is f prime of x, using the limit definition. So the derivative of the given function is 4x negative 3.